All right. You're basically doing three medians. Okay? You're doing three medians and the greatest and largest number. Now, in general, what a box and whisker plot is going to look like is this right here. You have a number line. Okay? You have a number line, and then you're going to have a box. It looks something like that. Then you're going to have what they call the whiskers off of it. Okay? This is the median. This is the upper quartile. This is the lower quartile. This is the greatest, obviously. And this is the smallest. Okay? Now, obviously, your number line is going to have numbers on it. Okay, obviously. Excuse me. So, I want to do an example of all the steps. Now, there's obviously, it looks like a lot of steps. It's really not that hard. It's just in the sense of it takes a lot of work because you got to find medians. And probably of all of our statistics, mean, median, mode, and range, median's usually the hardest one to find. Okay, it's the one that's a little bit more complicated. People don't understand it as well. So what I want you to do is I want you to copy down the numbers on the 125, on page 125. I want you to copy down the numbers for number 5. Okay, copy down the numbers from number 5. Okay, the numbers are 38, 42, 50, 65, 82, 91, 88, 40, 34, 41, 71, 93, 87, 94. Okay? Now, step 1 is that we put those numbers in order from least to greatest. So the smallest number looks like 34. So I'm going to go 34, mark it out. Then I'm going to go 38. Then it looks like 40. Looks like 41, 42. And all the 40s, yep. Then it looks like I got a 50. Then I got a 65, yep. Got a 65, then I've got a 71. Then I've got an 82, it looks like. '87, 88, 91, 93, 94. Okay, so that's step 1. Okay, so I'm going to go ahead and erase those. Now I've got them in order. Y'all don't have to erase them. I'm just getting me more room. All right, next step. Step 1 was put them in order. Step 2 is find the median of the data. So I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14 numbers. Okay. All right, make sure I had the same amount that the book had. So the median then, if I have 14 numbers, I divide 14 by 2, and that gives me 7. So that means it's going to be the 7th and 8th number, okay, will be your median. So 1, 2, 3, 4, 5, 6, 7, 8. So those two are your median. So I'm going to take 65 plus 71 and divide that by 2, and that will give me the median. 65 plus 71 is what? 136. Divided by 2, 68. So my median is equal to 68. Now, was 68 either one of the numbers, 65 or 71? No. So, I'm going to divide my numbers in half. Okay? There's in half. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. 7 on each side. Okay? So this side is the lower quartile side. This side is the upper quartile size. Okay? So step 3, right? We're on step 3? Yeah. Step 3 says to find the median of the lower half of data. We call that median the lower quartile. So now I have to go and say, okay, I've got 7 numbers. So for the lower quartile, I have 7 numbers. So I take 7 divided by 2, which is 3.5. That means it's the 4th number. So 1, 2, 3, 4. So my lower quartile is equal to 41. Okay, now my upper quartile is going to be the 4th number as well. So that's 1, 2, 3, 4. So that's 88. So my upper quartile is equal to 88. Now, step 4 was what? Upper and lower extremes. Okay. So the lower extreme is the smallest number, 34. Upper extreme is the highest number, or the greatest number, which is 94.
May I have your attention, please? We have a problem with our sewer system that's currently being repaired. But in the meantime, if we could not dump any more water than we absolutely have to, would be appreciated. So do your best to not add any more water to the sewer tank. It should not take them a long time to finish it, but we're going to have to stop pouring water into it, or the guys cannot get down to it, access it to repair it. So if you don't absolutely have to run any water, please do not do that. Thank you.
All right, anyway, back to reality. All right. Now, so now we found the upper extreme, lower extreme. Okay. Now we're on step what? 5. And what does it say? So we're not on step 5, step 6. Yes, Nick.
So the lower extreme and the upper extreme is for all the numbers, not like half?
Correct. Yeah. Okay. Now, so I'm going to draw a number line. That's not going to work too close to the other numbers. All right, now, on my number line, I'm just going to put, my smallest number was what? 34, right? So I'm going to do 32, 34, 36, 38, 40, 42, 44, 46, 48, 50, 52, 54, 56, 58, 60, 62, and I'm not going to have enough room. Okay? So there's not enough room, then I need to do something else. Here's what we'll do. Okay? I'm going to go by fours. So 32, that's why you have erasers. 32, 36, 40, 44, 48, 52, 56, 60, 64, 68, 72, 76, 80, 84, 88, 92, 96, 100. Okay? You will notice that I didn't plot the numbers from the data. Okay? I'm just doing a regular number line. You don't plot the numbers from the data. You get your range of data, and you build a number line that has that range of numbers in it. Okay? Now, I could have done it, you could have done it by ones or twos or threes, but you're going to have a larger one. I don't want to, have one that's going off the page. Okay? Now, here's the next part. The box and whisker. The first thing is do my median, 68, and I'm going to put a point there above the number line. Okay? Then my lower quartile was what? 41. So I'm going to put it right there. Yes. Yeah. Okay, then my upper quartile is 88. So it's going to go right there. Now, I'm going to draw a box around the outer points, like so. Okay, and I'm going to draw a line through my median, my middle point. Now I'm going to label those points. 41, 68, 88. The last part is to graph my lower extreme and upper extreme. So 34 be right about there, and 94 would be right about there. And I'm going to go ahead and label those as well. Okay, and that's your box and whisker plot. Yep, it is. Such is life. Get over it. Don't really care. You're welcome. Glad I could be a, compassionate person for you. All right, now, here's how you read it, okay? Each one of these represents 1/4 of the data, okay? The further away or the closer that these two are, okay, means the higher concentration of numbers, okay? For example, let's say I had a box and whisker plot that looked like this. Let's say I had a box and whisker plot that looked like that. Okay, what that tells me is this. This set of numbers right here is very close together, meaning you probably have some repeats. Like you might have a 42, a 42, a 43, a 44, 45, 45, 46. So you've got some repeats because the concentration of numbers, there's not a big spread. Okay? The wider the space, the bigger the spread. This right here tells me that we probably have an outlier. In other words, we have like a 98 like we talked about the other day in the age group. You probably have an outlier or one or two outliers that are way out there, and then the rest of the numbers are spread into those numbers. Okay? Same thing on this side. This tells me that my concentration of numbers is pretty close together. This tells me that I've got a huge separation of numbers. Okay? But it still represents 1/4, 1/4, 1/4, and 1/4. Doesn't matter how wide the space is or how narrow the space is or how short the whisker is or how long the whisker is, it still represents 1/4 of the numbers. Okay, Grant? No, we're going to use that here in a second. Nick? You have a cat named Whiskers. I'll sleep better tonight knowing that. That'll ease my mind. I'll be able to not toss and turn tonight knowing that you have a cat named Whiskers. Okay? All right, now, let's say, for example, that these numbers represented test scores. Okay, not the one we did, but this one that I've put down here. Let's say that this equals 100. Okay, let's say this was 80. This was 77. This was 60. And this was 50. Okay. If that's what these are, if these are test scores, okay, about what fraction of the class made 80 or lower? What fraction of the class made 80 or lower? 3/4. Okay? Because I have 1, 2, 3 of the fourths below an 80, or 80 or below. Okay? So, obviously, as a teacher, if I was to see this data and say this was a test grade, now obviously if this is just 6 people in a class, then it's not a good representation, okay? It's not a good way to do it. But if you've got 30 people in a class, okay, and you see this, then, that's got to tell me I didn't make a good test. I didn't make a good test, or maybe you don't know the material good enough, okay? And so that's one way that we could draw a conclusion about this data. Okay, so we could say, hey, test scores were 80 or below, 3/4 of the class, should never be that way. Okay? Now, the other day we talked about a line curve. Briefly, I want to take just a second here. A line curve we talked about the other day, we talked about line graphs. Okay, and this is sort of on the grade thing here that we're talking about. With a line graph, there is straight line graphs, broken line graphs, and curved line graphs. Okay, a straight one obviously looks like this, like that right there. A broken one is going to be more of what you see these days. A broken one looks like that. Okay, a curved one, that's the one I want to talk about for just a second because it deals with grades usually. A curved one looks like this. Okay, they call this a bell curve. And it's what teachers use to sort of make sure that the way their tests are, the way their projects are, the way everything that they're taking as a grade is fair. And how they do it, and it's not necessarily fair, but they think it is. What it basically does is this. From here to here, you would say is the majority of people, right? Okay? And that would be your 70%. 70 to an 80. Okay? From here to here would be your 80 and 60. Here would be failing. Here would be 90 or to 100. Okay? And so you can see that your most people are going to be in that 60 to 80 range. And for teachers, most of them believe, or 60 to 90 range, or really 60 to 90. Most teachers believe that's the way, if you're doing your class right, that your grades should be distributing. Okay? Well, the only problem with that is when you use a small sample size. I'll give you a good example. My father was a math and physics major in college. He went to UTA. He double majored math and physics. Well, in his last physics class as a senior, there was only 10 people in the class. And his average in the class was a 96 for the year. But he got a D. His letter grade on his report card was a D, because the teacher graded on the bell curve. And so a certain amount of people had to make A's, a certain amount of people had to make B's, a certain amount of people had to make C's, and a certain amount of people had to make spelling grade. Same thing happened to me in college. In my college class, I had a marketing class. There was 250 people in the class. And my final average in the class was an 86. But the teacher graded on the bell curve. So an 86 was a C. The only problem was, a C in that class was from a 42 to an 87. So if you made a 42 in the class, you made a C. You're loving the bell curve. But if you were me, and I made an 86, and I didn't make a B, and it brought down my GPA, even though I made a B in the class. So bell curves and things of this nature, okay, like we talked about there with the box and whisker plot, they're good ways to identify maybe you're doing something right or wrong, okay, but it's not the way you should base all your grades in your class. All right? It's just not a good system. It basically, what they said is 10% need to make A's, 10% need to make B's, 10% needs to make 60 to 70, and 10% need to fail. Well, that's 40% of the class. So 60% of the class need to make 80 to 70 is what they say. Okay? Obviously, that's not a good way to figure out. I mean, how would y'all like for me to do that in this class? You would like that?
If I fail, I'm still getting B's, right?
No.
C, I don't know.
No, it wouldn't, not in this class. Because right now, most of your averages are in the 90 to 80 range. So that means somebody that made an 8 in the low 80s is going to have to flunk, even though you made in the late 80s, in the low 80s. So, so that's why it's not a good system. It doesn't reward you for your work. Now, for me as a teacher, the way I look at it is, if I've got, we give a test and 90% of the class made a 90 or above, that's not a good test. Okay, it was too easy. Okay, it was too easy. Either that or I'm just an exceptional teacher. Okay, yeah. Most teachers want to look at it as, well, I'm just an exceptional teacher. Well, that's not necessarily true either. All right, so that's the box and whisker plot. Okay, it's pretty long and drawn out as far as figuring out the information. Okay, let me see if I can find a quick one that has some numbers that we don't have to write 22,000 numbers. All right, number 9. Number 9, I think I can do fairly quickly. Let's go. I'll write them in order. Okay, number 9, the first one is 10. Yeah, 10. Next one is 14. 14. Is there 3 of them? Yeah, 3 14s. Next one is 15, only one of them. 20, either 19. Yeah, 19, then 20. 21, 25, 25. Okay. Now, this one has 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 numbers. Make sure that one, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay. Now, so that means it's the 5th and 6th number. 1, 2, 3, 4, 5, 6. What is halfway in between 15 and 19? 17. So there's your median. Okay, your lower quartile is going to be this half of numbers here. And it's how many numbers? 5, so it's the third number, so 14. Upper quartile is this set of numbers. That means it's going to be 21. Your lower extreme is equal to 10. Your upper extreme is equal to 25. Now, and then you would plot that, okay? I want to write the same numbers. You don't necessarily need to write these down. I want to write the same numbers, but I'm going to change something. All right, I wrote the same numbers, but I'm only doing 125 instead of 2 because I want to show you what happens when you have an odd number of numbers. Okay? We have 9 numbers, so that means the 5th number is your median. So 1, 2, 3, 4, 5. There's your median. Okay? Here's where it changes. Since the median is only one number, then the upper quartile of numbers is this. The lower quartile of numbers is that. It doesn't include that one number. That's already been used. Okay? The other ones we've been looking at had 2 numbers, where we're finding somewhere halfway in between, so it still belongs to the lower quartile, still belongs to the upper quartile. When the number itself is used, it doesn't belong to either quartile at that point. Now, here's what you have here. Now you have 2 in that section. Well, halfway in between 14 and 14 is 14. So that one's 14 for the lower quartile. The upper quartile is going to be these 2. What's halfway in between 20 and 21? 20.5. Okay, so that would be your upper quartile. Your median is 15. The lower extreme is there. Upper extreme is there. And then you would plot it. Okay, so that's what happens when there's an odd set of numbers. Okay, the actual number, the actual median is part of the data, so you take the numbers on each side of that number at that point. Okay, whereas up here, the number was halfway in between 15 and 19. So that's why we took this half as the lower quartile, and this half is the upper quartile. Okay, that's why we did it that way. Okay, and obviously you still have to plot them. Okay, so when you do the work, like that's number 9, this right here will be a grade, will be X's, and the box and whisker plot is going to be an X, several X's. Okay, so you're going to have both. So list it out. Do like number 9, just like I've done here. List out the median, lower quartile, upper quartile, lower extreme, upper extreme, and then come over here and do your box and whisker. Okay? It's not on the number line, it's above the number line. Some of them put below it, but for the majority, most people, the actual right thing to do is put it above the number line. Okay? Any questions? All right, so your homework over that, let me look here. It's due Monday, yes, because you have your test tomorrow. It is going to be 3.4, 1 through 13. In that group, I think you only have to do 4 box and whisker plots, and we've already done 2 of them. Okay, so the rest of them are answering questions about the box and whisker plot. Okay, now this is due Monday. That'll be, I think, the 29th, if I remember right. Tomorrow is your test.
After tomorrow, will they let us put like glowing paint on our shirt?